Hello everyone, and welcome to the webinar on architecting a mobile application for the cloud by 8K Mouth and Amazon Web Services. My name is Dan Martin, and I'm part of the marketing team at 8K Mouth. Thank you for your time, and I really appreciate you all joining in for the webinar today. Let me introduce the webinar presenters for the day. We have Jeff Barr, Senior Manager and Evangelist from Amazon Web Services, and Harish Ganeshan, CTO at 8K Mouth. What you see on the screen is the agenda for today, which will include an intro to Amazon Web Services, followed by an overview of the mobile landscape. This will be followed by importance of mobile backend and 3 use cases highlighting how you can use cloud for mobile applications. Please feel free to post your questions on the GoToWebinar window or send your questions to webinar@8kmouth.com. Thank you once again for joining us on the webinar by 8K Mouth and Amazon Web Services. Over to you, Jeff.
Okay, thank you all for coming, and thank you for the introduction. So my name is Jeff Barr. I'm coming to you today from sunny Seattle, Washington. I'd like to give you an introduction to the Amazon Web Services. So Amazon Web Services, or AWS for short, is a cloud computing platform designed to be flexible, scalable, and cost-effective, basically providing you technology infrastructure. And it's a really good fit for businesses of all sizes located in just about anywhere in the world. And when you are a consumer of any of the Amazon Web Services, you're utilizing all the knowledge, expertise, and tools that we've used to run Amazon's global web properties for well over a decade. When you hear about the cloud, it's actually very useful to think of it as a utility service. Utility in a couple different ways. First, in one sense, you really don't need to think about what's happening behind the scenes when you plug into your phone system or your electrical system. You count on the fact that there's a skilled team of professionals behind the scenes that are keeping that service alive and functional and properly scaled and monitored and maintained 24/7 without any real explicit attention from you. You just count on the fact that those folks are working behind the scenes for your benefit. Another important aspect of the cloud is the utility billing model, basically the fact that when you consume resources from the cloud or from your other utilities, you are doing so on a metered basis. Your consumption is measured, and then you're paying only for the amount you use. So you don't need to pre-allocate, you don't need to pre-provision, and so forth. And we'll see a bit more about that, what that means as we get deeper into the webinar. Let's go ahead to the next slide. So let's start at the big picture level. AWS has global infrastructure that's running currently in 8 different locations around the world. Each of these different orange boxes is what we call a region, and each region is a separate collection of what are further subdivided into availability zones. You could think of each availability zone as an independent data center. It's really important that you know that when you choose to start doing any processing or any storage in a particular region, your information and your processing is always confined and local to that region. So there's never any movement of data from region to region without your explicit command to do so. There are currently 4 separate AWS regions in the US. There is another and relatively new one in Brazil. There is another one in Europe, and there are 2 in Asia Pacific, both in Singapore and Tokyo. When you're using our AWS Management Console, which is a visual tool for visualizing and seeing and controlling and launching different AWS resources, you can simply go to the region menu and you can select any of these regions from the menu to control your processing and your storage and so forth. The smaller red circles represent what are called edge locations, and from these locations we serve up content from our content distribution network, and we also serve up responses to DNS queries from our domain name servers. Next slide. This is a very high-level block diagram of the entire collection of different Amazon Web Services. I'm not going to go into any real detail on any particular service, but it's really important to know that we have a very broad collection of services, and that when you as a developer start to think about making use of those services, you have the ability to pick and choose from among them, and you can use exactly the set of services that are right for your application. Our typical customers will start out with applications architected to use a small set of services, often maybe some storage and some compute. Over time, they'll expand to more different types of services as their knowledge, as their skills, as their experience expands. At the lowest level of this diagram, we have our global infrastructure. This consists of what I showed you on the previous slide. The regions located in 8 different locations around the world, along with the edge locations, of which there are currently about 24 edge locations. And then within each region, as I mentioned previously, we have a number of availability zones. The idea of the availability zones, you could think of these as data centers. Each of the availability zones inside of a region has independent power, cooling, physical security, network connectivity, and so forth. We always advise you to build your applications in such a way that you distribute your processing across several availability zones in the region. That way, if there might be any kind of a temporary issue affecting one zone in a region, your application would be built with automatic scaling and load balancing to automatically put that load off onto other zones in that same region. Building up from there, we have a number of foundation services. For example, on the compute side, we have something called EC2, the Elastic Compute Cloud, designed to give you access to servers on demand. You can launch servers in any one of 11 different sizes, ranging from a micro server with a modest amount of processing power and RAM, up to much larger instances with multiple cores, large amounts of RAM, and so forth. We have multiple different kinds of storage services, including Amazon S3, which you may have heard of, an object-based storage system that currently holds over 762 billion objects. AWS includes a number of database offerings, both relational and non-relational, which people are now calling NoSQL. For example, we have the relational database service to make it very easy for you to launch both MySQL and Oracle managed database instances in the cloud. And with SimpleDB and our new DynamoDB are both offerings in the NoSQL space. We have a number of networking offerings, including load balancing, security groups, and what's called the virtual private cloud for enterprise and corporate use. With the virtual private cloud, you can create a walled-off section of the public cloud. You can assign your own IP addresses and IP address ranges. You can create routers. You can create subnets. And you can then use an encrypted VPN connection to attach that virtual private cloud to your existing corporate network. Building on the foundation services, we have higher-level services for various types of content distribution, Amazon CloudFront. We have a number of messaging services. We have publish and subscribe messaging. We have notifications. We have email delivery. On the parallel processing side, we have a service called Elastic MapReduce to make it very easy for you to take very large problems and then use the power of Elastic MapReduce to apportion sections of that problem to tens or hundreds or thousands of processors running in parallel to subdivide the work, process it in parallel, put the results back together. As a developer, you might be interested to know that we have a number of different libraries and software development kits to give you access to all the different APIs, the programming interfaces embedded in these different services. Moving up from there, we have a visual administration console so you can see and manipulate and monitor your different AWS resources. Various forms of identity and access management to give you fine-grained control of exactly who is able to access within your account, who's able to access different resources. Services for deployment and for managing complex workflows. And then a service called CloudWatch to allow you to monitor and then set alarms based on different parameters that you might want to monitor for CPU load, network traffic, and so forth. So this is your menu that you can use to actually design and build your mobile applications. Again, really important to know that you would always choose to make use of some subset of these services in any particular application. The AWS architecture is very open, very flexible, and you can pick and choose from among different services as needed. Next slide. Now I'd like to go into a little bit more detail on Amazon EC2 and the related services. The idea with EC2 is you have access to servers on demand. These servers can be running either Linux or Windows. We have multiple different flavors of both Linux and Windows. When you launch a new server, you always do that in a particular region, and then you choose a particular availability zone in that region. You always choose from our catalog of Amazon Machine Images, which we call AMIs for short. Each AMI consists of a base operating system, and then any tools, applications, utilities, and so forth that you choose to pre-install onto that AMI. So you can create an AMI with an entire application stack on there, freeze it, and then launch as many copies as you would like. So in order to access that instance running in a particular zone, let's start with that web traffic at the bottom. You have the ability to create a load balancer in that cloud. You can then put any number of instances behind that load balancer. You regulate IP traffic access to your instances by means of EC2 security groups. By default, the instance has no access because there are no security groups attached. When you choose to launch the instance, you'll generally attach one or more security groups, and you will pre-configure IP addresses and ports and protocols into those security groups. So you might say, this is a web application. I'm going to enable port 80 access from anywhere in the world. And I'm going to have a management address on port 22 for SSH access. Maybe I'm only going to allow that access from selected IP addresses on my corporate network. Network traffic in, network traffic out, disk activity rates, and so forth to CloudWatch. Those metrics are collected every 5 minutes by default and made available both to you in API form and in the console, and also to use to drive auto-scaling activities. So the combination of CloudWatch, auto-scaling, and load balancing turns out to be very powerful. For example, what you could do, you could use CloudWatch to monitor the average CPU load across a load balanced group of instances. You could then set a CloudWatch alarm that says, if that load average remains above 80% for more than, let's say, 5 minutes, we'd like to raise an auto-scaling event. When that auto-scaling event fires, we'd like it to add an additional instance to the load balancing pool, put that instance into the pool, and then apportion traffic across that additional instance. So in this way, after you've properly designed and architected your system and your alarms, you can automatically accommodate any amount of traffic by simply using CloudWatch plus auto-scaling plus load balancing. On the downhill side, you can have another rule that says if the average traffic across all those instances remains below 20% for more than a certain amount of time, you'd like to take one of those instances out of the rotation, destroy the instance, and then reduce your hourly consumption of EC2. You have a number of directly attached storage options for EC2. The first is called Elastic Block Storage. With Elastic Block Storage, you get to create virtual disk volumes that can be anywhere from 1 gigabyte up to 1 terabyte in size. You create these volumes, attach them to your instance, and use those if they were local file storage. These are better than file storage in that there's intrinsic redundancy behind the scenes with Elastic Block Storage. You also have the ability to detach it from one instance and attach it to another instance in the same zone. At any point you'd like, you can take snapshot backups of your EBS volumes to Amazon S3. You can then use those snapshot backups to recover the data to a fresh instance. You can use this for data recovery, to distribute data around your region. You can also use this as part of your scale up and scale down activities. Next slide. We get a number of questions about AWS security, and we know that our customers take security very seriously, as do we at AWS. We have a complete AWS Security Center that's available to you at aws.amazon.com/security. In there, you're going to find a number of really important details about our security setup. You'll find a number of security white papers. You'll find a compliance white paper. And in those white papers, you're going to find information about various certifications that we have worked to achieve with AWS. You'll find details about our physical security, and you'll find information about how we manage our network, our hardware, and our software. As you can see on the list, we have obtained a number of really important certifications for AWS, things like SOC 1 Type 2, which was formerly known as SAS 70, ISO 27001. We have obtained PCI DSS, which is necessary for credit card processing for a number of the core services. For federal government use, we have obtained the FISMA moderate set of controls. And we have a number of customers building HIPAA applications for healthcare. On the physical security side, we have a very, very detailed description of all this in our security white paper. I would definitely encourage you to read that. Our data centers are nondescript facilities. We are very, very strict with physical access controls. If you as an Amazon employee need to enter one of our data centers, you must pass at least 2 levels of two-factor authentication before you have access to a particular floor. We log and audit all of the accesses. On the hardware, software, networking side, we are very systematic about change management. When we roll out new software throughout our network, we do that in a phased model. We decommission all storage by demagnetizing and then shredding all magnetic devices. And there's a large number of monitoring and auditing features built in to the system. And one more slide, please. Next slide. Okay, so on the last thing I'd like to tell you about before we turn things over to Harish, we have a number of mobile SDKs, software development kits, to make it really easy for you to build AWS-powered applications on popular mobile devices. Both the AWS SDK for Android and for iOS provide you with a set of local libraries, code samples, and documentation that are all set up to let you build connected mobile applications using AWS. These are free SDKs available to you on our website, and they're very straightforward and easy to use, full documentation, code samples, and so forth. So that's your actually, let's go for one more slide, and then we'll switch over. Okay, so let's kind of sum up. Why would you want to use AWS for mobile applications? The first reason will be flexibility. As we've discussed, you have access to a very wide range of services. With the AWS pay-as-you-go model, you're able to align your capacity and your spend rate with your growth, so you don't need to invest in data centers and servers up front, and you simply add additional AWS resources as your application grows and becomes more popular. You can scale easy with AWS. We talked about load balancing. We talked about the worldwide footprint. And you can very easily increase the number of servers, databases, the amount of storage, and so forth. And finally, you can access AWS through a wide variety of access methods. Various different components of AWS use services like JSON, BSON, which is the binary form of JSON, SOAP, REST, HTTP, and the secure variant of HTTP. We talked about the SDKs. And you can build and run apps in a wide variety of different languages. We've been moving pretty fast here because I want to make sure that Harish had plenty of time to cover all of his content. So I do thank you for listening. And Harish, let's turn things over to you now.
Thank you, Jeff, for setting the context and giving a very good overview into the capabilities of AWS. I'm Harish Ganeshan. I'm the CTO and co-founder of AK Miles. AK Miles is an Amazon system integration partner, and we have been working with them for the last 4 years, building solutions and providing solutions and implementations over Amazon Web Services. So in this webinar, I'm going to delve more into the mobile cloud architectures. And first up, to start with, I'd like to present few stats about the mobile apps. So we know that like iTunes App Store has got nearly more than 500,000 approved apps, and Android market has 300,000 approved apps. Smartphone is used for food shopping by 43% of US owners. By 2014, the mobile internet should overtake the desktop internet usage. iPhone owner has nearly 50 plus apps, and Android owners have on the average 35 plus apps. 26% of the time, the smartphone users will never use the same app again. So this is something that we should, all the app builders, the mobile app developers should understand. 1 in 4 mobile apps once downloaded is never used again. So over 300,000 mobile apps have been developed in the last 3 years. And the tablets generate nearly 21% of the mobile traffic to the retailer sites. So this is another small stats about the smartphone usage. 67% of smartphone users either research or shop on their mobile phone. 53% was the year-on-year growth
on the app downloads. 95% was the year-on-year growth for the time spent on online social gaming. And 54% of business travelers have downloaded travel-related app on their mobiles. So all these things are made possible by the power of the mobile backend. So we are observing in the last few years that mobile cloud computing is emerging as a new paradigm. Mobile applications are becoming highly intelligent, and they are leveraging the user's location, context, data, and network intelligence for considerably improving the user experience. Such complex mobile applications usually require very, very solid backend architecture with elastic processing and memory power. So now in this webinar, we are going to see how we can harness AWS for developing and implementing such mobile applications. So I'll be addressing this through 3 architectural cases. The simplest case is dealt first, and the complex enterprise case is dealt at the last. So I request the attendees from enterprise to wait till the last case, where we have shared all our experiences and insights in coming up with such architectures. So first up is the cloud is your storage case. We'll see how to architect and implement a simple mobile application using AWS SDK for iOS and Android. This is a simple file storage mobile app which uses AWS SDK to store the information in the cloud. The mobile users can upload multimedia and other files to the AWS using this app. The mobile app has 2 versions, one for iOS and another for the Android. Previously, developers used to write their own libraries to handle the HTTP connections, the requests, retries, error handling, everything. With the AWS mobile SDK, they can develop the applications leveraging the AWS resources with simple, straightforward SDKs. So the AWS SDK for iOS requires Xcode v3.2.3 or later to work. It requires iOS 4.1 or later to work. AWS SDK for Android requires at least Android 2.1 with API level 7 or higher to work. When developing a mobile application that interacts with the AWS using SDKs, we need to decide whose credentials to use for authentication. In some scenarios, the end users of the mobile application will have an AWS account and use his or her own credentials to access the AWS resources. In real scenarios, when many end users want to access the AWS resources, like S3 or SimpleDB, through the mobile app developed, it's not recommended to embed our own credentials within the mobile application. So there is a concept called as token vending machine, which uses AWS security token service for handling these types of scenarios. AWS security token service is a feature of Amazon Identity and Access Management. The security token service provides the temporary security credentials to qualify and allow access only to specific AWS services or to even subsets of the functionality provided by AWS. The temporary credentials are limited, and the maximum time the temporary credentials can remain valid is only 36 hours. So for example, if we have a temporary credential that could be configured to allow only access to simple storage service, or only to a particular storage bucket within S3 service, it could be done using the token vending machine. In a typical implementation, the mobile application has got a TVM client library in the device. The mobile app calls the TVM to request the temporary credentials for a user. The TVM requests the temporary credentials from the AWS security token service and then passes the credentials back to the application, which is the mobile client. The application uses these temporary credentials in subsequent interactions with the AWS. When the credentials expire, the application contacts the token vending machine for the new credentials again. There are two mechanisms to access the token vending machine. They are either anonymous TVMs, TVMs are the token vending machines, or the identity-based TVMs. As the name suggests, the anonymous TVMs works based on the global unique identifier and a secret key, whereas the identity-based TVM works on the registered username and password. So TVMs are a server-side Java WAR files, which can be hosted on containers like AWS Elastic Beanstalk or on Apache Tomcat on AWS. Using token vending machine in combination with IAM policies, we can control the user access to a specific S3 bucket or a simple DB domain or specific actions what they can take on a S3 or a simple DB. So a mobile app can use the AWS SDK for iOS and Android and upload the multimedia and other files into the S3 buckets and the tag and the other meta information into the simple DB. Using the AWS SDK for iOS and Android, we can address simple scenarios and use cases. It might not be suitable for complex multi-tenant SaaS applications which requires heavy customization. And it's also not suitable for enterprise scale mobile applications. So now coming to the cloud is the processor case. We'll see how to architect and process a process-intensive mobile backend dependent cloud application. What are the characteristics and requirements of this application? What are the best practices that needs to be adopted while building and implementing this mobile application? This particular mobile application that we have taken in the case is a productivity app. The users can upload and share contents. They can send their sales PPTs. They can have the to-dos for buying medicines. It could be your restaurant information shared by your friend, pictures of your favorite moments. So all these contents will be synced between the mobile devices to the backend immediately. The users can also tag and search for the contents whenever and wherever required. So some of the characteristics of this mobile application are, it is 70% read and 30% write in nature. The notes, to-dos are written once. The uploads are done once, but usually read and viewed multiple times over a period. It's highly concurrent usage with requests, having peaks and valley-based load patterns in a day. More to-dos and notes are done in the evenings and mornings. More image uploads are done in the evenings and lunch. And the requests, the concurrency varies between few thousand concurrent requests per second. The variety of data stores are needed in this application in the backend to store the files, to store the images, the tags, and the to-dos. And also we have seen like heavy processing is required in the mobile backend for image conversions to low resolutions, medium resolutions, and multiple sizes, for file conversions to multiple readable formats. Synchronization between different data stores are needed. The search result processing is needed. Analysis, clustering, and classification of data is needed. So what are the requirements of this mobile cloud application? The mobile app should support and run on iOS and Android phones and tablets. The information should be accessible from the desktops as well. JSON, HTTP, and REST-based communication should be supported between the mobile app and the AWS backend. The data should be kept fresh and always available. For example, the to-do notes on my phone should be available immediately on my tablets and desktops as well. The user base is constantly growing month on month, which means the processing and the CPU needs to be added in the mobile backend elastically to serve the users. To serve these requirements, it is obvious that the mobile backend that we architect and we design should be highly available and scalable. So now let's see how we can architect this particular mobile app use case. Since the content will be uploaded and viewed multiple times from the multiple devices like phones, PCs, and tablets, they have to be centrally stored and delivered from the AWS cloud. So the multiple web app EC2 instances are placed under the elastic load balancer and receives the information from the mobile through the JSON or HTTP or REST protocol. The web app instances passes the information to the business service layer, which stores the information in the database, and RDS MySQL is used as the database. RDS is architected to run in multi-ASI mode for high availability. When the files and images are uploaded from the mobile device, they are received by the web app EC2 instances. Since MySQL is not the best place to store these kind of information like files or images, the original files are moved to S3 buckets, and the meta information is put on a simple queue service for processing. The number of processing EC2 nodes are triggered based on the custom CloudWatch parameter. The processing nodes picks up the metadata from the queue, locates the files from S3, converts the image files, extracts the information from PDF, doc, and text files, converts them to readable formats, and updates the information back to the relevant data source. Since the file contents can be searched, they are stored in Solar Shats. Solar is a blazing fast open source search platform with powerful text and geospatial features. The data is sharded into multiple Solar EC2 instances for better performance. For scalability and high availability, the web app processing, the business services are deployed in multiple availability zones of Amazon. Like as Jeff mentioned, availability zones are distinct physical locations having low latency network connectivity between them inside the same region. They have independent power, cooling, network, and security aspect. Now the question is, after we have a lot of web servers, a lot of app servers, processing nodes running, can the MySQL RDS handle thousands of concurrent requests from hundreds of EC2 instances simultaneously? The answer is no. So the solution for this is to introduce a sophisticated key value pair NoSQL to handle the concurrent requests. But if you see again, it requires a lot of maintenance, it requires rebalancing, scaling, additional complexity, and it's an additional headache for the IT ops. So we decided to introduce Amazon DynamoDB into this architecture to address this concern. So Amazon DynamoDB is a fully managed NoSQL database that is fast, that gives predictable performance with seamless scalability. Using DynamoDB, we can scale up or down the request capacity for the table without downtime or performance degradation. DynamoDB stores all the data items on solid-state drives for single-digit latency response. DynamoDB automatically replicates data across multiple availability zones in an Amazon region to provide high availability and data durability. The entire infrastructure is monitored using CloudWatch and other monitoring tools. The notes, the to-dos, tags, comments, the reviews, user info, the meta information, all are stored and accessed from the DynamoDB. The Solar search typically stores only the searchable contents. The MySQL RDS stores only the critical transactional data, and S3 stores all the files. The processing nodes constantly synchronizes the information between all the data stores. All the components in the data store layer that's shaded on the gray are deployed across multiple availability zones for high availability inside Amazon. The case that we discussed now is not only applicable to productivity apps, but many elements of this architecture and best practices can be applied to the mobile apps in social sharing, in media space as well. So now moving to the final case, cloud is your extension. So in this case, we'll see how to architect a mobile cloud application for an enterprise. What are the characteristics of this application? What are the unique challenges and intricacies that an enterprise brings into the table for a mobile cloud architecture, and how we can solve them using AWS? The application taken in this case is a booking and a user profile app for an airline company. Every quarter, a sales promotion is offered by this airline company. Many customers use their mobile app to make their bookings during this promo period. Since the data is transactional in nature, it needs to be highly available and accessible from multiple channels and devices. For example, the tickets might be booked through the mobile and printed through the PC. The flight schedules can be viewed. The check-in processes can be done through the tablets. So this is the way in which the information is accessible anywhere in this application. So now let's see what are the challenges and constraints enterprises impose on this mobile cloud architecture. The challenge one is that the mobile app is not a completely isolated app for an enterprise. The airline mobile app, this particular app, talks to CRM systems residing in customer data center 2. It refers to critical user data from another data center, and it uses the email services running in data center 2. So this is just a sample, and sometimes we see that the mobile channels have more interconnections and complex integrations with other systems running inside the enterprise. And if you see, the complexity here is not all the integrations are safe to be accessed over the internet without any protection. Secondly, not all the systems are exposed to even internet. Some of them might be accessible only from the internal network. Now the question is, how are we going to integrate these systems from the mobile cloud? This is a very critical point, because if the complexity cannot be addressed, the enterprises cannot have the mobile app interacting with the cloud as a backend itself. So now coming to the challenge 2. Enterprise is always concerned about security. HTTPS, DMZ, identity access, multi-factor authentication, encryption, VPN, authentication and authorization are some of the terms which we'll have to seriously address when we are architecting mobile cloud for them. Enterprises will never want their mobile app and their backend to be the weak link in their infrastructure. The challenge 3. The mobile backend will sometimes use third-party web services in their applications. Some of these third-party customer gateways will require the IP address of the calling servers to be whitelisted in their firewalls. Sometimes the mobile backend will receive feeds from third-party services, which needs to be displayed on the mobile app. Whitelisting of the IPs might be needed in both the cases mentioned. If these third-party services are an essential part of your mobile app functionality, and if the whitelisting of the IPs is in bottleneck, it could jeopardize the entire feasibility of the mobile cloud architecture itself. So what are the characteristics and requirements of this mobile cloud application? The mobile app should support and run on iOS and Android phones and tablets. It would necessarily use JSON-based communication between the mobile app and the AWS backend. Periodic load bursts were observed only during the promo time. The mobile backend should have the ability to burst and serve from thousands to millions of requests during the promo period. Since the data is transactional in nature, it should be fresh and it should be up to date when accessed from multiple devices and mediums. Since 70% of the business for the quarter is done during the promo season, the mobile backend availability is very critical for this business. Now let's see how to architect the mobile backend in cloud for this airline booking application. Since security is one of the main concerns for the enterprises, the entire backend solution is architected inside Amazon Virtual Private Cloud. Amazon VPC is a private isolated section of the Amazon Web Services Cloud. Public and private subnets were created inside the Amazon VPC for DMZs. The load balancers and the web app servers were placed in the public subnet. The application data stores were placed inside the private subnet. The mobile app talks to the web app servers over the internet using the JSON protocol. Every web app EC2 instances in the public subnet is assigned with an elastic IP so that the IP range is whitelisted in the third-party service gateways and firewalls. This also enables the mobile backend to securely call the third-party web services over the internet. Since the mobile app requires information from user database in customer data center 1, and it also talks to the CRM and email system in the data center 2 for bookings, a VPN connectivity is created between the Amazon VPC and the existing customer data centers. The virtual network topology in Amazon VPC is architected to resemble and align with the traditional network present in the existing data centers. Using the VPN tunnel, the mobile backend can now securely integrate to the CRM, to the user database, which are not exposed over the internet to the outside world. For achieving scalability, multiple web app servers were launched inside the VPC subnet. Depending upon the load pattern, they are load balanced to the elastic load balancer. Since availability of the mobile backend is very critical for this business, especially during the sales promos, the entire infrastructure in VPC subnet 1 is replicated in VPC subnet 2. Also, the VPC subnet 1 and subnet 2 are deployed in two separate availability zones inside the AWS for high availability. The infrastructure inside both the VPC subnets are kept active by the load balancers during the promos. This was done specifically for having better performance and better cost efficiency overall. This architecture, if you see, is a perfect example of how a mobile cloud can extend your existing IT assets in a secure way and also help you to reap the benefits of the cloud like high availability, scalability, cost efficiency without compromising the mobile user experience during heavy loads. This enterprise mobile cloud case is just not relevant to the travel or booking industries alone. It is also applicable to wide varieties of companies in e-commerce and media space as well. E-commerce companies can keep their mobile catalogs, carts, mobile social apps in Amazon Cloud and access their inventory and order system through the VPN using the Amazon VPC. So this gives a kind of extension. The cloud now is acting as an extension to your existing IT assets. The media companies also can keep their mobile content in the cloud and the rest of the core systems in their existing data centers. In short, if we see, architecting mobile cloud solutions using Amazon will be a powerful extension to your existing IT infrastructure assets. So what are the benefits of having AWS in your architecture? You can scale the capacity on demand. So during your sales promos, for 3-4 days alone, if you need a massive capacity, we can ramp up the capacity in Amazon to serve the requests and to have the sales promo user experience done really well. Or if we have a peak and valley kind of load, in a day if your load goes up and comes down, we can use Amazon auto scaling and combine it, which seamlessly connects with the elastic load balancer, have all our web app layers running on it, and it will handle the capacity on demand. So we can keep our data fresh in variety of data source. Like as Jeff also explained, Amazon offers variety of data source. There is like RDS, which is an RDBMS version, and then there is SimpleDB, there is S3, there is DynamoDB. lots of data options are there to store. So as an architect, whenever we store information, we should choose the right kind of data store and leverage it in the Amazon. We can focus more on the product, not worrying much about the infrastructure and what will happen when my application becomes famous, when my mobile app becomes famous. You can go and always get more instances. You can programmatically write code and get more instances in Amazon. The overall, it would be really cost effective when you have large server farms running, and typically you can grow with AWS. So if we see a mobile app, whenever a mobile app is launched, a lot of doubts come into people's mind, like whether I would be successful or not. And the moment you are successful, in 1 or 2 months or in 6 months, you are going to reach thousands and millions of downloads. So your backend should be really capable enough to handle it. It is actually easier to grow with AWS for such scenarios. So it's just about AKMIs. We are an Amazon Web Services partner. We help companies leverage cloud computing, mobile and big data. We do solutions combining all these things. We have expertise across the entire suite of AWS products. We can help companies on migration. We can help companies on consulting. We can help companies on developing solutions over Amazon Cloud. And we have a team of experts located in United States, in India, and in Singapore. So now we can get to the Q&A. We have some filler slide having the contact information to reach us, and we'll open the floor for questions now.
Thank you, Jeff and Arish. This was very insightful and informative. I'm sure the audience felt the same. We got a list of questions, and I will have Arish and Jeff answer them. Question to Jeff, is there a limit to the number of concurrent requests that Amazon DynamoDB handles?
Okay, so that's a really good question, and the way that DynamoDB works is that it has this model that we call provisioned throughput. With the provisioned throughput model, when you create a DynamoDB table, you simply tell us how many read units and how many write units you would like us to provision the database for. Each read unit or each write unit represents a transfer of 1,000 bytes as part of a get or a put. So let's say by default you configure you're doing relatively short operations, small amounts of information. You might say I'm going to start out and configure for 5 reads per second and 5 writes per second of up to 1,000 bytes apiece. Okay, so you set DynamoDB up like that, and we will provision, we'll spread your data and the processing out across a sufficient number of storage devices and servers. You start to do your operations. You're putting a certain amount of data using a certain amount of write capacity as you store. If at a certain point you use more than that, we'll give you the rated capacity you've created your table for, and we'll also raise a notification that your application can look at through CloudWatch to see that you're at your rated limit for capacity. If you then look at your situation, you decide, well, my application has become more popular, I need more reads, or I need more writes, you can either call the DynamoDB APIs, or you can go to the management console, and you can, while the database is running and while it's processing puts and gets, you can go ahead and you can provision more capacity. So maybe that initial 5 and 5 turns out that you actually do a lot more reads than writes. So maybe you double the reads from 5 to 10. And then as your application scales, as your user base expands, you can continue to add provisioning by adding that capacity while the database is online and while it's serving up the full amount of provisioned capacity. Hope that makes sense for you.
Question to Arish. What instance type do you recommend for Solar Shad?
Okay. Solar is a search engine, and typically it works with when you give it a lot of memory, and we usually recommend people to at least start with a large instance type in Amazon, which is a 64-bit with 2 cores and 7 GB of RAM. The more the memory you provide to Solar, the better it functions and performs. And but generally, if you see, like there is no such thing as the fixed instance type or something that we recommend. Usually, we do that as part of the load testing. We find out like what kind of latency is expected and what is the number, what's the amount of data that's being stored, the number of records that needs to be indexed. So keeping all these things in mind, we usually design and architect a Solar shard. Not all the times also it would be Solar shards. Certain times it could be just Solar-based replication. So when the data is more and if we are not able to handle it even through replication, then it should come to shards. So to summarize, starting with M1.large for many cases and decide it based on your load testing.
Question to Jeff, is the AWS SDK for iOS and Android open source?
Are the SDKs open source or not? I do believe that they are. I believe we actually have Git repositories for both of those SDKs. But let me check, and I'll get back in a little bit later in the webinar with that information for you.
Okay, question to Jeff, what is the advantage of using DynamoDB over Amazon SimpleDB?
Okay, so another great question. SimpleDB was our first offering in the NoSQL space. And with SimpleDB, it has a couple of features that, while very, very powerful, have actually turned out to limit its scalability somewhat. So, for example, with SimpleDB, we automatically index all of the item values and attributes that you store for every item. That turned out to be very, very handy from a programming standpoint because you can retrieve anything that you'd like and you don't have to arrange for an index. However, it does incur a certain cost as far as storage overhead and processing overhead. And also with SimpleDB, each of your domains that you set up is limited to 10 gigabytes of stored data. With DynamoDB, we've changed things a little bit. We've set DynamoDB up so that we have unlimited throughput, so you can read and write as fast as you'd like. You have unlimited storage, so you can scale your database up as large as you need to. But we also put a restriction in place that says each piece of information is identified either by a primary key, which we call a hash key, or a hash key that also includes a numeric or string value, which we call a range key. So we've constrained the ways that you can retrieve data with DynamoDB in exchange for giving you a control of throughput and giving you as much storage as you would like.
We have a question from Andrian. This question is for Arish. In case on AZ crash, what happened with the elastic load balancer? Is the elastic load balancer located in AZ1 or AZ2, for example? AZ1 crashes, all of the IPs are redirected automatically to AZ2.
Okay. The best practice whenever we are architecting solutions on Amazon is to leverage at least two or more availability zones. So let's take a case that we have the web app servers. We should see that the web app servers are distributed among two or more availability zones. Now, these web app servers will be configured either with auto-scaling or without auto-scaling. And whatever the configuration is, it can talk to the load balancer can sit in front of it. The load balancer can seamlessly send the traffic between these web app servers in multiple availability zones. So let's take a case when availability zone 1 fails. The load balancer now does an health check and finds that the web app server residing in availability zone 1 is not returning any values. So it basically now starts redirecting all the load or traffic to the web app server in the availability zone 2. So this is done automatically. It's done based on the health checks and based on certain configurations that we can do on the ELB. The ELB itself is not a service that is tied to particular availability zone. It runs on region, and on the region if you have set up all the web app servers to run on multiple availability zones, you can serve and direct the traffic to all the web app servers in all the availability zones. So this is how the ELB works.
Question to Arish. What monitoring tools do you use for the enterprise?
Okay. So this is a very good question actually. So for an enterprise scenario, we don't go about with just one monitoring tool. It's a combination of monitoring tools is what we usually recommend and what we implement for the enterprises. It could be starting with CloudWatch. With CloudWatch, we do all the aggregate measurements. We also do custom parameters, custom CloudWatch parameters, where we take up certain parameters, custom parameters, we write code, and we pass it over to the CloudWatch. And the CloudWatch pretty much can effectively monitor all the Amazon Web Services. And it gives a lot of metrics and stats. And for application level monitoring and infra level monitoring, we go about with the Nagios. And we use the Nagios for a lot of implementations. And for application level, we depend upon certain times we use New Relic. So these are all certain tools that we use on the monitoring for the enterprise.
A question to Jeff. Currently, in which region DynamoDB is available? When is it expected to arrive for Tokyo and APAC?
Currently, DynamoDB is available in the U.S. East region. We have plans, but I don't have dates to share with you currently to expand to other AWS regions later this year. Please check back with us or check with the AWS blog or the AWS newsletter to learn when we expand.
Question to Arish. How do you back up RDS MySQL?
Okay. So RDS is a managed service of Amazon, and it comes up with its own configurations for the backup. So we can configure an RDS that take backups periodically every hour or every day. So at the specified intervals and times, it starts taking the backup. And over this, we can also do RDS snapshots. We can write custom scripts where we can take RDS snapshots as well. Or we can use the Amazon Management Console to manually take certain backups. So these are all certain things that we do as part of the backups in RDS.
We have time for one more question. A question to Arish. Is PHP version for token vending machine available?
Okay. I think currently it's only a Java-based WAR file that's available on the token vending machine. I think Amazon would come up with PHP versions as well. Jeff, you want to take it?
Yes, I believe that's correct. The token vending machine is available in Java in the form of a WAR file. Also, while I'm, if I could follow up on that earlier question, both the AWS SDKs for Android and for iOS are available in source code form. If you go to the home pages on our site for those SDKs, at the bottom of the page, there are links to the GitHub repositories for the source code for each of those SDKs.
Thank you once again for joining us on this webinar today. We appreciate your time spent with us. Please feel free to send us your questions to cloud@8kmouse.com, and we will get in touch with you. Thank you very much.
Thanks, Jeff. Thanks, Harish.
Thank you.
Welcome.